decided to record a video to support the problem set. Here is a problem that I made in 2017, so 8 years ago, I guess, for University of Hartford. I guess this was homework 5 for them. So anyway, so there's a little bit of solid modeling that needs to be done for this problem project or problem set. And I figured I would do an example to help out people who might find some difficulty using SolidWorks for it. I've just chosen this one randomly. 2 inches wide. I didn't specify the length of anything. And then it goes down to 1.25 inches with a 3/8 inch radius. And then it goes down to, again, to 1.25 inches. And then so there's a 3/4 inch hole right in there. I hope this is not too identical to the problem set, as I would like to have it challenging, but I also don't want to make it too difficult. So I'm going to make the model first. Hopefully I'll remember all of these things. I probably have to flip back to it. So I'm going to start a new part here and get along with this. Get rid of the smog with the beach blanket on, the beach ball on a blanket. There you go. And I'll make it on the front plane. You can make all this in one sketch. Sometimes I find, just as general advice to you, that that's not the greatest idea. It's almost better to make things in make pieces and then make cuts out of it instead of trying to make a complicated sketch. So I think I'll approach this in the most sensible way right here. It's symmetric, so we actually technically only have to make half of it in FEA, but we're going to go ahead and do it anyway in the manner that I was showing. We're going to do it this way, but just to make it look like the piece. But in terms, since it's symmetric about this axis right here, we really only have to make half of it. So let's see. I guess I'm going to use symmetry for this. The length is a little arbitrary. We can kind of look at it, and I think I'm going to make it maybe 4 times the width. I'm just eyeballing it there. So that would make, what, 8 inches long, just to separate the stress concentrations from each other. And so there you go. We'll make it this way right here, and then I'll extrude it. And I don't have to go halfway down the plane, but I am gonna. So I'm gonna make it 1/2 inch wide, but I'm gonna go mid plane for it. So point. I could have just done. Okay. Anyway, boom. Now I'm gonna put the notch fairly close to the middle, maybe a little off to the side, because I don't want it to interfere with this over here. So I'll make that a sketch on this face. And here's, I'll show you the generic case. Yeah, that'll probably be best. I'll make the generic case. And just in case you have, I'll try to explain what I mean here in a second. Okay. So that right there needs to be 1/2 of 1.25. I should be able to do that in my head, but I think it's going to be 0.625. But I'm actually going to get my calculator and check if I can find my calculator. Where'd you go, Mr. Calculator? Oh, there you are. I should clean my desk. 1.25 divided by 2. Oh, look at that. Yay for math. Okay. So what I'm going to do here, and I'm sure there's lots of different ways to do this, by the way, is I'm going to pick it somewhere onto this line. Make a circle somewhere, but connect it to that bottom of that construction line. And my purpose, and by the way, I think I can still move this around. Yeah, I can still move it around. All right. So here's what well, hopefully you'll see in a second what I was talking about. I'm going to make a line like that and a line like this. Boom. I think I got it right. Okay. And now I'm going to trim this off. All right, so this is my cutting tool. I guess I have to trim both sides right there. This is my cutting tool. And now I can make the radius of this match my 3/8, 0.375. 0.375. Boom. All right. So just looking at that, by the way, it looks to me like that just nicely landed that radius right onto here. I mean, the end of that circle right onto that line. But that's not always going to be the case. Let me get rid of this and show you that we could perhaps make a notch that looked like that right there and still have the requirements of the dimensions. This is the reason why I made it this way, in case yours does. We can also, by the way, we could make this so large that it went like that right there, right? So that point could be up above there. It just so happens with these dimensions that we can go with it, that it lands right in the right spot, 0.375. All right, I'm just letting you know that for modeling. I'm also, let's see, I'm gonna, you don't have to give the length to this right here, but I'll make it just 1. All right, so we're almost defined, and then I'm going to pick its location. I guess I'll go 3.5. Right, so I decided not to be directly in the center. I guess 4 is fine. I think it's long enough that it's going to be fine. Yeah. So I'm going to do this in another. I could also make a cutting tool that also made the other part right there at the same time, but I'll do it in stages. It's just good practice. You make a really complicated sketch and you could really drive yourself nuts. Now I'm cutting this through both. Notice, so I use that cutting tool right there. I said cut extrude was underneath was the feature. I think it's like right there. Yeah, cut extrude, and I cut through both. Right, so you can see that in the preview. It's going to do the thing I want to do. Boom! I just made my notch. So I'll do this as well. Make a sketch on that face, and I will. Oh, that should be horizontal. Let's see, that should be vertical. Make it, click onto it. You can add a relation, and it doesn't really matter too much how far that is. Oh, I see. Okay, see, I accidentally made that in the middle. That's a good spot for it, so we're gonna leave it there. This right here should also be 0.625, right? And now we put in our fillet right in here. And the fillet radius should also be 0.375, 0.375. And it won't let me do it. 0.375. All right, so it's not gonna let me do it. That's okay. Let me get rid of that fillet now then. Let me go undo. I'll do undo. I think I can cut this with just those 2 lines. Sometimes you have to have a closed thing. It used to make you do a closed section for it. So I'm gonna have that. Let's see. Yep, and it's doing through both. Okay, so, and I think is it gonna leave it? Yeah, okay. And now I can add the fillet in. It didn't like making the fillet right to the edge, right onto the thing. So let me go 0.375. Boom. It's not giving me a preview for some reason, but it did make it. Okay, so it did make the thing. And then now I'm going to mirror it. I'm going to make it's going to be easier to make the hole in one spot. So I'm going to mirror all the things. I think the body, so the mirror face is going to be right there. And I guess you could do features to mirror, faces to mirror. I think I can do bodies to men, but we could do all of this. Boom, 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 right there. I think I need to have all of those. Well, except that it forgot I didn't put the fillet in there. Let me mirror the fillet. There, bro. Mirror the fillet. Boom. Oh, rebuild there. It didn't like it. It doesn't like that fillet. Let's get. Well, we'll instead of fighting it, I'll just go ahead and put another fillet in. It didn't really want. It didn't want to do it. Okay. So we saved ourselves how much? No, not much. All right, and it should just put it in, right? Okay. And then lastly, I'm going to put the hole onto it. And it's probably easiest to use a construction line. So I made that right here. And this should be 3/4 of an inch, right? Because they all should have the same value, essential radius, 0.75. And see, you don't want this circle too far to this end, and you don't want it too close to this. I'm gonna go 1.5 eyeballing. Maybe 2 might be too close to it. Is it 2 going to be too close? I think 2 is going to be fine. Right. So once again, I'm going to cut that through, and it's going to go through all. All right. So good. Boom. So we have it. We should probably save this. It's always good practice to save as, and let's see, class 9 examples. I think I'm going to make this into PS. Is this problem set 3? Let's see. I forgot what number we're up to. What's mad at me? He's not going to let me. What assignment are we up to? We are up to. It's not problem set 2. It must be PS4. Problem set 4. PS. Whoops. I gotta change that name. No. It's not gonna let me rename it. Problem set 4. Stress concentration example for video. Saving it forever. All right, now make a SolidWorks simulation. Come to simulation. We got a new study. We only have static to choose from, so we'll go yes, and then proceed through our normal thing. Coming down the list, we'll apply material. Material doesn't really matter too much. Pick anything you want. What does it say in the assignment? What it is? It's it's cast iron. So if you want to, you can make cast iron. It's not going to make any difference, really. You get ductile iron, gray cast iron. You don't even have many choices to the thing. Just hit apply. Made it kind of black, a little dark. Makes it look like cast iron. Doesn't matter. Skip connections. Remember, those are only for assemblies. And this is just a part. We'll fix this end. And then onto this end, we'll put the load. External loads is just going to be a force and 5,000 pounds, huh? And it's going to be English units, 5,000. It looks like that's in compression right now. Let's go reverse the direction. Now it's in tension. Okay. And let's accept it. And let's hit a mesh and mesh it up. I'm going to take the default. Actually, well, no. Yeah, let's take the default. Yeah, it's kind of hard to see, probably. I hope we can see that in the video. Let's get that stupid darkness to it. Let's hit run. And we can set up, should run pretty quick. All right, and let's set up what our results are. All right, so edit definition, right click edit definition. And first off, we don't want von Mises stress because hopefully we'll learn about that soon. That's not what we're dealing with. We only want stress in the x direction. And we would like to have, KSI is nice. I think everything in here is fine. We can have a deformed shape. Who cares? You can see this really exaggerated by 143 times is the default right now. In the settings, let's keep the mesh in there. And let's make that discrete. A lot easier to understand. And let's make our units something useful. All right, so it's all intention. So the scale should have a 0 as the bottom. And it looks like it's going, well, it kind of defaulted here to about 18. Let's go 15 so we could see. That sounds about right. We might want to change it to, we'll see if we have to go up to 20. We'll change this to floating. And I really only care about about 2 decimal places, so we don't need more than that. And now because we made 15, let's go 15 here. So we have nice little increments of 10 or thereabouts. See? Okay. So we've used our colors effectively. And now let's take a look. I should show you something, and I will in a moment. All right, we will do this in a moment. You'll note that, and you'll see why we're doing it. Well, this is actually probably a good order to do the thing, and you'll see why we have a problem. First off, this might be a better analysis to do in 2D instead of 3D, because the thickness, things that have changed through the thickness shouldn't matter, but you can kind of see a little bit already that it's not completely even along the thickness of the thing. So that's a variable that we could remove by taking the 2 dimensions. And there's not necessarily a node that we could pick on when we go to a probe, like right here. You can see this is not meshed sufficiently, because you could just look at the amount of color change that are taking place across the elements. You get that element right there. It says it's 12.28, whereas this element right here is 11.82, and these are over 10.6. There's a lot of variation going across the elements, and even there, 11.27, just right across the elements. We need more elements, is what we discover. And let's have the probe over here, because so these are mid-side node of 15.84, and down over here we have something right around 19. Let's take a look and see what we predicted, and we can do that right away. For our stresses, see, I'm saying that the hole right here, A, should be 18.16. I'm saying here at the notch B, we should have 14.4. And lastly, over here, we should have 12.8. All right, so let's see if we can remember that. 18.16. 14.4 and 12.8. So 19, we're in the ballpark. 15, so we were saying, what we say, 14.4 for there, and then for right here, we were saying 12.2. Anyway, so we could do a better job, right? We can increase the mesh. Before we do, though, there's something that's very useful to doing an analysis like that, and that's to make a cut line, so that it forces nodes onto a line. So that is a nice feature to have. And to do it, I found the best way is to make planes and use planes. So we have a right plane right there, and I am going to copy it with my reference geometry underneath features. And I'm going to move it 2 inches. To line up, boom, right there, okay? And I might actually need to do with this. Oh, that puts me right in the right spot. What about there? Nope. So I'm not going to do all 3. I'm just going to put those 2 right in there. So we have these 2 planes. We'll hide them in a minute. I'm going to make another plane off of that plane, and I think I'm probably not correct here. that, I'll move it like that. It's probably, the max is going to be probably right around there or right there. We can probably move. I think right around there is about where the maximum is going to be located. We could do a little better job later on. All right, so these cut lines, what they essentially do is they make like one of these, but they put right there where the intersection. So you'll insert curve split line. I said cut lines, but I meant split lines. And so there's a silhouette, projection, intersection. I can never remember which one. I think it's the intersection, where I want to take a plane. Okay, you see there's a pink and a blue. You got to pick the right one. I think I'm going to pick that, and then I'll pick that surface. And you can see in a preview, it's going to add a split line right there. I think I can do this in one step, like all right there. Might as well cut them top and the bottom right now. And then same thing here, boom and boom. So you can kind of see it made all my split lines. Now it renumbers faces when you do that, so it might give me an error back in my FEA. Let me we'll fix that. Okay, so let me hide all three and grab all of them to see the little. No one wants to see the lines. All right, so first off, okay, so the force is fine. See, I thought maybe the force would be messed up, and maybe the fixture, because it renumbers all the faces. So this face might have gotten renumbered, and so it gets confused to where the force is located. So let's go ahead and we'll create a mesh. It's going to say, no, didn't say it. I thought it would say it. All right, so we're going to solve it again, run it. Let's see, and you can see now what we could do is we have, for sure, we have a line right there. And when we go to plot tools, instead of going for probe, we can go and we can grab that line right there. I'll hit the update button, and now you can see the average stress. You see the max, the min, and then the root mean square, but the average is usually what I will use. Or I'll use a two-dimensional thing, and don't need that. Then I'll have I still will put a split line in there, by the way, so I have a node exactly where I want it. But you can see that we got a value of like 17. So I think it's just a more accurate way to approach it, a more systematic way. All right, so here this guy has an average of 14.89, and I'm clearing this, and I'm going to look at that line. Okay, so that line didn't actually go to the maximum, but I can't really quite tell, honestly. That just has a maximum of 9.65. I can't quite tell where it's going to end up because we don't have enough nodes. So now we have to proceed with a mesh study. What we can do is, if we want to, okay, sure, is just ramp that global mesh over to the side. We can see we have a lot more nodes. Let's run it and see what happens. We should probably be recording these numbers, by the way, and then graphing them a little bit just to see how they look. But we're just looking at the results. All right, so we get a little bit better of an idea, and sure enough, you can't quite capture. Let me go back down to this one first. Plot tools, list selected. It'll let me select either that or that, right? So I need to move it a little bit down. Not very scientific, I know. Let me go ahead and move it. I think I'm probably going to move it. Well, let's see. It's somewhere in between those two lines, that line that naturally formed over here and here, right? So we actually kind of need right there. So I didn't do a very good job. I can move this by another, yeah, there's a good spot, right? I think. All right, so we just moved the split line, and now let's remesh, create mesh, losing all the answers. That's fine by me, I don't care. And let's solve it, run it again. No audio detected. What? It says I'm very quiet. I haven't been accused of that in a long time. List selected. There you go. I got it in just about the right spot. Update. It's saying an average of 12.85. What we were saying it was, we were predicting 12.8. Geez, that might have been an accident. Let's see if we could do better with the mesh, with a more refined mesh, by going to mesh here and going add mesh control. All right, so I'm going to put it only on the split lines. And I'm going to do it all at once just to make my life, you know, just a little bit easier. Actually, I could probably put it on both lines right here. Wouldn't hurt. All right, and now I'm just going to hit fine all the way across. So hopefully, when we create the mesh, just tell that thing to go away. Hopefully we'll see, yeah, more localized nodes, localized in each of those spots, and run. We could, you know, we could have done this right from the very beginning, but it's just good practice to do a little mesh study. All right, and now we have a pretty good result, a pretty good looking thing here. Let's take a look at what our list selected does if we were to go one down, one after another right here. My average stress, 18.72. Back up to here, 18.16. Not bad. Would more elements help? I don't know. We could find out by messing around with it. That's the beauty of the thing, is we get to experiment with it. Right here, I'm getting an average of 15.74, predicting 14.4. It's a little more off. And then let's do a little over here, clear those up and update it, and we get 13.16 compared to what, 12.8. Well, not identical, but understandable. It's you know, we're getting a thing off, pulling a number off of a graph. There's a little bit of potential for error there. Let's take a quick look if we can. I don't think we can convert this to 2D now. So let's go and make another study, a new study. Let's see if we can make it 2 dimensions. So right here, ooh, it doesn't let me have the 2-dimension simplification. I need a higher quality version of the SolidWorks educational version, right? So that's interesting. Anyway, so there's a video to try to help you do the problem set, what do we say, problem set 4, doing a stress concentrations using FEA. That's enough. Talk to you soon. My audio is very quiet. I hope it worked.